This is Mr. Ayton, and this is 3.1, Unit 3. We're on a new one, circular motion. So let's take a look at what circular motion has to do. Let's take a look at linear motion. We've just been taking a look at our forces with linear motion, and we saw some big things with linear motion was whenever we had a constant speed, the sum of the forces, the net force, was equal to 0, which means there's no acceleration, right? Constant speed, the acceleration was equal to 0. But in circular motion, it's different, because in circular motion, when we have a constant speed, we actually do have a net force. The net force is constant. Okay, whereas the acceleration is also constant. We actually have a number for acceleration whenever we're moving at a constant speed in circular motion. Let me give a little more detail to that. There's three main things you need to know when you talk about circular motion that is different from linear motion. The acceleration is always constant, and it's towards the center. We call this centripetal motion, centripetal acceleration. Centripetal means towards the center. And there's a nice easy formula for that. That's the centripetal acceleration is equal to the v squared, the velocity squared, over the radius. The sum of all forces, number 2, the sum of all forces is constant, and it's towards the center. Again, the sum of all forces is centripetal. So the sum of all forces are always equal to ma, which means it's always equal to m times the acceleration, that is centripetal. So it's just mass times your acceleration, mass times v squared over r. The sum of all forces centripetally is mv squared over r. And lastly, number 3, the speed is constant, and the velocity is going to be tangent to the curve. The velocity is changing because the direction is going to be changing, but the speed is going to be constant. And that equation for that is the velocity is equal to the distance over the time. The distance of a circle is going to be the circumference, 2 pi r. The time is going to be the period in seconds that it takes to get around. This little picture shows so much. Look at this acceleration. The acceleration is centripetal. The acceleration at every single point is towards the center. And so will the sum of your forces will be towards the center at any point. But look at the velocity. Look at the red line. The velocity is going to be tangent to the curve. The velocity is going to be tangent to the curve. So that you can see the velocity vector, even though it's constant, the speed, the size of the arrow is the same. Even though the speed is constant, the velocity is changing because it's changing direction. So let's take a look at 2 of these problems. We're going to take a look at a vertical circular motion problem. And first, let's take a look at the top. So first, let's take a look at the top. At the top, let's draw my free body diagram. We have our bucket. Of course, it has a mass times gravity is going to be going down. And there's also going to be a tension. The rope is going down. And so you can see, do I have a sum of my forces? I sure do. My sum of my forces, which are equal to ma, and in this case it's going centripetally, so it's mac, is equal to the tension plus the mass times gravity. Why is it added to both? Because they're both going towards the center. They're both going centripetally. So what do I know about this MAC? It's the same as mv squared over r. Okay? That's what the sum of your forces. The sum of your forces centripetally is going to be mv squared over r, equals to my tension plus my mass times gravity. So I plug in some of my data here. My mass is going to be 10. My velocity is going to be 6 squared over my radius. My radius of the rope is 2 meters long, equals tension plus mass times gravity, 10 times 10, which is going to be 100 newtons. Okay? And when I do the 10 times 6 squared over 2, it's really like taking 36 times 5. And 36 times 5 is equal to 180. So 180 is equal to the tension plus 100. So what's your tension equal to? Your tension is about 80 newtons for this problem. Okay? That's at the top. Let's take a look at our circular motion at the bottom. Again, we're going to do a free body diagram. My mass times gravity is towards the bottom. My tension now is towards the top. And you can see the sum of my forces are always equal to ma, and in this case it's mac because it's centripetal. And what is going towards the center? The sum of my forces are always towards the center because the acceleration is towards the center. So tension will be positive because that's going towards the center. What's going to be negative, and sorry about that, what's going to be negative is the mass times gravity, okay? And so again, we take our mv squared over r is equal to my tension minus my mass times gravity. And my mv squared over r, I have my 10, I have my 6 squared, I have my 2, which ends up being the 180, just like in the previous problem. Tension minus 100, so here I have tension minus 100, and you can see what minus 100 equals 180. Of course, that is going to be 280 is going to be equal to the tension. And what happened to the tension at the bottom of the string? The tension increased big time. So guys, 3 things you got to know. The sum of our forces are always towards the center centripetally. The acceleration is always towards the center centripetally. And the speed is constant, whereas the velocity is tangent to the curve. Guys, I hope this helped out. And I'll see you in class. Bye.